Hello, everybody. In Module 1, I provide introduction to theory, discuss traditional models of capital markets, and explore how disclosure affects various capital market outcomes. Module 1 has 6 lessons. Today, I'm focusing on lesson 3, Grossman-Stiglitz model. Grossman-Stiglitz model is an information economics model. Information economics models are quite different from traditional microeconomic models you may encounter. One key difference is that in traditional microeconomic models, price only plays an allocation role. Demand equals supply that generates price. But in information economics, price has an additional informational role. I would like to use analogies to illustrate that. Microeconomic models are like chess. There is no private information and everything is observed publicly. Information economics models are like Texas Hold'em. In Texas Hold'em, your opponent's cards are their private signals, and your opponent's actions or strategies depend crucially on their private information. You want to make an inference about your opponent's actions or strategies. How you would do it? You will put yourself into your opponent's shoes and conjecture what they're going to do as a function of the cards they have. For example, what they're going to do if they have 4 and a kind, what they're going to do if they have a flush, etc. As we discussed in lesson 2, the inference, the conjectures, cannot be arbitrary. It has to be reasonable, which means in equilibrium, it has to be the same as the actual choice. So for example, conjecturing your opponent is going to fold, even if they have royal flush cards. It's not going to be reasonable. As a summary, information economics models, information would be distributed unevenly, and this plays an important role in those models. In all information economics models with prices, a crucial issue is how to infer others' information from prices, because price aggregates everybody's demand, and so it aggregates others' information. Such inferences depend on how price is formed. As in microeconomics, we talk about 2 different types of markets. The first, perfectly competitive market when everybody takes price as given. The second, imperfectly competitive markets when somebody has market power. Their demand moves prices, and they're going to take that into account when choosing their demand. Regardless of the type of markets, important concept in information economics models with prices is how much information can be inferred from prices, or what we call price informedness or price efficiency. Grossman-Stiglitz model provides a precise definition of price efficiency by formally modeling how to infer information from prices. So now let's look at the model. There is a continuum of traders with constant absolute risk aversion utility function, or CARA utility function. Their risk aversion coefficient is rho. The continuum assumption can be used to justify that everybody takes price as given because everybody is negligible. The traders are trading on the shares of a firm that has a terminal value U, which is uncertain at the time of trading. U has a prior normal distribution with mean mu and variance 1. Because we're studying how to infer others' private information from prices, you need to have others that are privately informed. So there is a proportion lambda of traders that are privately informed. Each of them is going to observe a private signal that is U plus some noise. The precision of the signal is S. The rest, 1 minus lambda, is uninformed. And of course, they have to learn from prices. We're going to see that even the informed traders are going to learn from prices. Price is determined by demand equals supply. So you need to have a supply of shares. Grossman-Stiglitz assumed that the supply of shares is a random variable X, which has a normal distribution of mean 0 and variance V. And you're going to see why we need this very shortly. Because of the CARA utility function, because of normal distribution, it's very natural to guess and eventually verify a linear price function. And the linear price function is also very intuitive. It puts some weight on the prior mean mu. It puts some weight on the average of the private signals, because there are a lambda proportion of privately informed traders, and their private signal is U plus noise. So when you average them, noise cancels out, you get a lambda U. And like all price functions, price is going to decrease in supply. So that's where the minus gamma X term comes from. The beta and gamma are endogenous coefficients that eventually will be determined. You can see in the price function that price reveals some information about U. And so observing price is equivalent to observing a suitable linear transformation of price, which is some noisy signal about U. This means that price contains information than even what the informed traders know about, which means that informed traders would like to learn from prices as well. This is intuitive because each informed trader has only his or her private signal. The price aggregates private signals of every other informed traders. And Grossman-Stiglitz has a precise definition for price informativeness. Because price is U plus noise, so price informativeness is determined by the variance or precision of the noise, which is also the precision of price in revealing U. So now, how to solve the model? Current utility combined with normal distribution means that we can write the demand function in a very nice, intuitive way. In general, the demand function is the expected value of U conditional on the information you have minus the price, divided by risk aversion times the variance of U conditional on the information you have. So first look at the numerator of the demand function. If conditional on my information, my expectation of U is bigger than the price, I'm going to buy. Otherwise, I'm going to sell. So the numerator is very intuitive. The denominator determines how intensive I'm going to trade based on my information. If rho is bigger, I'm more risk averse. I'm going to trade less. If variance of U conditional on my information is larger, there is more uncertainty. And because I'm risk averse, I'm going to trade less intensively. And that explains the denominator. The only difference between the demand function for informed traders and the uninformed traders is that informed traders, they observe their own private signal in addition to price. So for informed traders, it's conditional on their private signal and price, but for uninformed traders, it's only conditional on price. And because U is an exogenous variable, as we discussed in lesson 2, you can use Bayesian updating to calculate the conditional expectations and conditional variances of U. And then you can write out the demand function for informed traders and demand function for uninformed traders. And then market clearing is going to determine the price. And it eventually turns out it's a linear price. So each informed trader's demand is different because their private signal is different. So you have to integrate over their demand. For uninformed traders, they observe the same information price. So their demand are all the same. That explains the market clearing condition. And then you're going to match coefficient because you conjecture a linear price function. Now the conjecture is confirmed. To match the coefficients, you will have two equations for two unknowns, beta and gamma. Those are not linear equations, so it's not guaranteed they will have solution. However, eventually, we can solve for beta and gamma using the two equations. You don't need to solve that by hand. Nowadays, you can solve by software such as Mathematica. And those are the expressions of beta and gamma. Once we have beta and gamma, we can determine the price informativeness because the price informativeness depends on beta and gamma. And inserting the expression of beta and gamma into the expression price informativeness, we have the price informativeness is S squared times lambda squared over V. So this is very intuitive. It means that the price informativeness increases with S and lambda, and it decreases in V. Remember what S is. S is the precision of the private signal. The more precise the private signal is, the more informative the price is because price incorporates the private signals of traders. The higher lambda is, the higher the price informativeness. This is also very intuitive. When lambda is higher, there are more informed traders. So price will reflect more of the information. And price informativeness decreases in V. This is also very intuitive because V represents the amount of noisy trading. When V is higher, there are more noisy trading, which means that price is going to be less informed because there's going to be more noise in prices rather than reflecting informed traders' private signal. And we can now see why we need the supply of shares to be noisy. Suppose the supply of shares is not a random variable, which means that the variance is zero. Then in that case, price informativeness is infinite, which means that the variance of price is going to be zero. So in this case, price is going to fully review U, which means that the informed traders, they don't need to rely on their own private signal because their own private signal is just a noisy signal about U. But price now fully reviews you. So they just rely on price. They don't use their own private information in trading. But in this case, how can price aggregate informed traders' information? If you think further, if information acquisition is costly, and if informed traders can learn you from prices, they don't have incentive to acquire their private information signals. But if they don't acquire their own private signals, how can price review their private information? So that's why we need the supply of shares to be noisy. Now, this is a technical assumption, but in reality, we can also find assumptions to justify the noisy supply. For example, you could trade for non-information based reasons. For example, you need money to buy a house, you need money for medical treatments, so you need to sell shares. Or you win the lottery, and then you have a lot of money, so you want to buy shares. Those are non-information based trading, which explains the noisy supply. So as a summary, when there are private informed traders trading in the markets, price is going to aggregate their information. And so price is going to be informative of the underlying fundamentals of the firms they're trading. Grossman-Stiglitz formally shows how you model this and provides a precise definition of price informedness. In the next lesson, we're going to discuss how we model disclosure in Grossman-Stiglitz model and how disclosure affects various capital market outcomes. If you want to test your understanding of this lesson, a quiz of this lesson is provided at the link in the slides. Thank you very much.